This is the brief on mass accumulation in varying geometric densities. Okay, so what's this all about? Well, this research looks at how total mass piles up inside different 3D shapes. Think cubes versus spheres. But here's the twist. The density of the matter increases with the square of the distance from the center point. So the further out you go, the way denser the stuff gets. So what did this study really prove? 3 critical takeaways just jump right out. First, it's all about radial distance. Seriously, it's king. Because that density ramps up so dramatically, the total mass of any shape is going to be overwhelmingly dominated by the material that's located farthest from the center. Second, the object's geometry is a huge deal. When you compare a cube and a sphere, the sphere captures significantly more mass. And why is that? It's because the sphere's uniform shape is just way more efficient at capturing all that super dense material way out on the edge. And finally, this whole principle holds up even when you look at really complex shapes, like a torus, a donut. The math showed that the hole in the middle contributes almost nothing. All the mass accumulation is focused right on that big outer rim, reinforcing this whole idea. This analysis confirms that when density depends on the square of the distance, maximizing your radial boundary is the key to capturing mass.